Hello. This lesson is on secants, tangents, and angle measures. It's section 9-6. Let's get started. A secant is a line that intersects a circle in exactly 2 points. Lines J and K are secants of circle C. When two secants intersect inside a circle, the angles formed are related to the arcs they intercept. Theorem 912. If two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So the measure of angle 1, which is right here, is equal to 1/2 times the measure of arc AB plus the measure of arc CD. The measure of angle 2 is equal to 1/2 times the measure of arc DA plus the measure of arc BC. Let's do some examples. Example 1. Find the measure of angle 1. The measure of angle 1 will equal 1/2 times the sum of 40 plus 52. The measure of angle 1 is equal to 1/2 times 92. So the measure of angle 1 is 46. 46. So it's inside the circle. So this angle, measure of angle 1, is equal to 1/2 of the 40 plus 52. Let's look at example 2. The measure of angle 2. Okay, so angle 2 is here, and we have ourselves 48 and 38. Okay, so we're going to find this measure here first. We'll call that 1. And then we've got ourselves straight line here. So we can subtract that from 180, okay, to get our measure 2. So that's how we're going to do this one. We're going to start with this angle, find this angle here, and then we will subtract from 180 to get angle 2, okay? So let's start with that first. Measure of angle 1 is equal to 1/2 times the sum of 48 and 38. Okay, so that is 1/2 times 86. Which is equal to 43. So the measure of angle 1 is 43. Okay, so if this is 43, angle 2 will be 180. Measure of angle 2 will equal 180 degrees minus 43. And that's equal to 137. Letter C. So if you have this type of problem on B, you're given these two, but you're trying to find this other angle. You got to find this angle first, subtract from 180, and you get 137. Okay, C. We're going to work with this one now. We have the angle measure of 60 degrees. So if that is the angle measure, that is equal to 1/2 times the sum of the x degrees plus the 25. Plus the 25. So here we're given the angle measure, but now we're going to find the arc, one of the arcs. Okay, so we're going to call that x degrees. Okay, so let's get rid of this half here first by multiplying both sides by 2 on this side and this side by 2. So you get 120 is equal to these. This all cancels out. 120 is equal to x plus 25. And subtract 25 from both sides. You have yourselves x is equal to 95. Okay, so keep a lookout on those types of problems. So here you're given the angle measure, 60, and you set up your arc. You're adding your two arcs, take it times 1/2, and your algebra to answer that JK is 95. Okay, moving right along to letter D, the measure of arc GH. Okay, so let's call that X. Okay, we have this to be 28 and this to be 45. So in this case, we have 45 is equal to 1/2 times the sum of x plus 28. Okay, just like we did in C here, we're going to multiply both sides by 2. Okay, I'm going to multiply this side by 2 and this side by 2. And then we can proceed to do your algebra here. 90 is equal to x plus 28. Okay, so in this one, again, they're looking for this arc x. So if you add the x plus 28, take it times 1/2, you're going to get that angle 45. So by subtracting the 28 from both sides here, you're going to end up with an x is 62. X is 62. And that would be letter D. Last one on the first page here, we have the measure of JMK. So we're looking for this measure here. We're going to call that X. Okay. We do have this arc here, HJ and LY. So with that in mind, we can find this angle here. This angle, we're going to call that Y. Okay. So if we find that, we can subtract that from 180 and we're going to get our X. So we don't have this arc here or this arc, but we do have the other two arcs. That's going to help us get that angle, okay, angle Y. So the measure of angle Y will equal 1/2 times the sum of 79 and 77. And with that in mind, you have is equal to 1/2 times 156. So Y is 78. Y is 78. Okay, so we're looking for this JMK. So this is 78, which is going to be this angle. Okay. So JMK will equal, we're going to just call it X now, is equal to 180 minus 78. 180 subtract 78, and you have yourself 102. 102 for the measure of angle JMK. Got 5 pages of notes, really only 4. This is the first page. Section 9.6. Okay, second page. Recall that we learned a theorem back in section 9.4 that stated that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. If one of the sides of this angle is tangent, this relationship still holds true. Let's take a look at theorem 9-13. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So for instance, if we're looking at the measure of angle 1, that is 1/2 the measure of angle AB. Here's angle 1, and if here's AB, the measure of angle 1 will be 1/2 of this arc. Likewise with measure of 2. Measure of angle 2 will be 1/2 the measure of ACB. ACB. It's got to be on the circle. It's got to be on the circle. So let's take a look at example 2 here, and let's go through some of these. A couple of them are going to be pretty quick. The measure of angle 3. All right, so this is the measure of angle 3 is equal to 1/2 times the 220. And that's 110. Letter B, the measure of RT. So you've got 74 degrees. So in this case, we're looking at the measure of RT all the way around, which is all the way around the circle is 360. So if we can find this part here first, which is going to be 2 times 74, 2 times 74 will equal the 148. Okay, so remember, if you look back, the measure of this angle is 1/2 of the arc, okay? So if you multiply this times 2, you're going to get 148, okay? So the arc here is 360, so the measure of arc RT, okay, is equal to 360 minus 148. 360 minus 148, and that is equal to 212. 212. 212. So remember, the measure of the angle is 1/2 of the measure of the arc. Okay, so again, this was 74. We doubled it to get 148. And we subtracted the 148 from 360 to find the measure of RT. Moving on. Letter C. The measure of angle ABD. The measure of angle ABT. Okay, so this is going to be X degrees. So we're looking at ABD here. And if this is 154, we're going to first take 360 and subtract 154. And that's going to equal 360 minus 154, which is 206. Okay. 206. So this arc here is 206. We're looking for this angle here. So it's 1/2 of 206 will be the angle. And that's 103. So again, angle X is 103. The arc we subtract from 154, 206. And that is letter C. Letter D. Measure of angle 6. Okay, so we have 228 going around here. And because we have 228, we can take 360 and subtract 228. And that's going to equal 132 for the arc. So this here is 132. And since that's 132, the measure of angle 6 will equal 1/2 of 132. Okay, so if this was given to you as 228, we subtracted from 360 to get 132. And now we're going to multiply that by 1/2 to get this angle, angle 6. And that's 66 degrees. One more on this page, letter E. Okay, so you've got this, we're looking for G, J, F. So they want us to find this G, J, F. We're given that this 82 degrees is here. So because of this is 82, we're going to know that this arc here is double it, 164. Okay. Well, if this is 164, we know all the way around is 360. So this will be 360 minus 164, which is equal to 196. So keep a lookout for these types of problems on the upcoming work. Theorem 913. Not too tough. Let's go on to the next page. Secants and tangents can also meet outside a circle. The measure of the angle formed also involves 1/2 of the measures of the arcs they intercept. Two secants, a secant and a tangent, or two tangents, intersect in the exterior of a circle, then the measures of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Okay? So let's take a look at all three of these diagrams. We have two secants here. Measure of angle A. The measure of angle A will be 1/2 the difference between the measure of arc DE out here and the measure of arc BC here. 1/2 of the difference. All right? Let's say you have a secant and a tangent right alongside the circle there. Then you've got 1/2 times the measure of DC minus the measure of BC. That would be the measure of angle A. You also can use this theorem for two tangents. If you have two tangents running out here, you're going to have 1/2 times the measure of BDC minus the measure of arc BC. Okay, so we've got a series of questions here that we're going to answer today. And let's get started. Find each measure, assume that segments that appear to be tangent are tangent. Okay, so we're looking for the measure of angle R. So in this case, the measure of angle R will equal 1/2 the difference of 120, okay, this arc here, minus 40. That is 1/2 times 80, or 40. Letter B, we're looking for the measure of angle U here, right there. Measure of angle U. Okay, so we got 144 here. I got 60 here. And 144 and 60 is 204. So this little arc here is 204 from 360, and that's 156. 156. Okay? So we found that this was 60, this is 144, which is 204. Subtract from 360, you get 156. Okay, so now we can find this little angle U. So the measure of angle U is equal to 1/2 times the difference of 156 minus 60. Okay, so again, back to what we were given. We were given parts and pieces of the circle, and we have to find this arc first by using 360 degrees minus this sum of 144 and 60. So now we can go ahead and solve using our theorem. 1/2 times 156 minus 60, which is 96. And 1/2 of 96 is 48. So the measure of angle U is 48. Okay, letter C, L. So that one was easy. Here you got 102, all right? So what you can do, if you are given that this is 102, we're just assuming it's right there to there is 102, we can subtract from 360 to get our arc out here, which is 258, okay? 258. All the way around the circle is 360. So 360 minus 102 is 258. So if we're looking for this angle, it's outside of the circle, we can find that measure of angle L by taking 1/2 times the difference between 258 minus 102. So again, keep in mind, look at what you're given there, 102, subtract from 360, and you got your 258. So now we can go ahead and use our algebra here. 1/2 times 156, and that is 78 for letter C. 78. Okay, 3 more on this page. Measure of angle K. Okay, it's got K way out here. Now again, we've got 100, 72, and 140. Okay, 100, 72, and 140. If you add all these together, you get 312. Subtract from 360. This is 48, this arc here. So I'll put that in right away. 48, okay? So 100 plus 72 plus 140 is 312. Subtract from 360, you get 48. All right, now we can find this angle K. So the measure of angle K is equal to 1/2 the difference of 72 minus 48. So we're looking for that angle K. 72 minus 48 is 24. So we have 1/2 of 24, and that's 12. So again, on this case, they're giving you 3 pieces. Find the last piece on the circle. and go from there. All right, letter E, measure of angle S. Okay, so we have the this arc as 45, okay? And it appears that this is a diameter, okay? It goes through the center, all right? So if this is 45, we can subtract from 180 now to find this arc, okay? So 180 minus 45, 180 minus 45 is 135. Okay, so this arc is 135. And let me just put that down there, 135. All right. So keep that in mind. Look out for diameters, firing through there. And now we can go ahead and solve for measure of angle S. 1/2 times the difference of 135 and subtract 45. And that's equal to 1/2 times 90. And 1/2 times 90 is 45. And that's letter E. So that angle on the outside of the circle, and it's got a tangent and a diameter shooting through there. And keep in mind you've got to look again what you've got, 45, and they're giving you that diameter. Okay, last one on this page, letter F, measure of QTS. QTS. Okay, so we know the angle measure is 71, so you already know that. So we know the angle measure, and that's equal to 1/2. We're going to call this arc. We're looking for QTS. We're going to call it X. Okay? So 1/2 times the X minus the 106 will get you that measure of 71. So you're given the outside angle, 71. And what you're going to do is set up your equation. 1/2 of the X, the arc X, minus the 106, okay? So let's go ahead and do some algebra here and solve for X. We're gonna multiply by 2 on both sides here, all right, to get started. Then we'll have 142 on this side is equal to X minus 106. 106. All right. So 142 is equal to X minus 106. Okay, so now we're going to add 106 to this side and 106 to this side. And you'll have 248. 248 is equal to X. So keep a lookout for those types of questions. And we have 1, 2. Oh, continue on this same concept in these next 2, but one more page. Okay. Okay, so here you have 15 degrees. So we're going to start with that. We have the angle 15. So that's going to equal 1/2 times the difference of 59. Then we'll call this X. And that's what we're looking for, GJ. Okay, so 59 minus the X. 59 minus the X. I'll make that a better 5. All right, so then we're going to multiply by 2 on both sides because we have that 1/2 there. And we'll end up with 30 is equal to 59 minus X. Okay, a number subtract from X, and you end up with 29. So we're going to subtract 59 from both sides. 59 from both sides. You would get negative 29 is equal to the negative of X and then divide by -1, and you would get x is 29 degrees. So keep a lookout for that, where you're given the angle measure on the outside, and you're looking for one of the arcs. Last one on this section, then we have one more example, is this guy here, CE. We're looking for CE, okay? So we're going to first call this X, okay? That's what we're trying to find, is this little X. And if this is X in this type of problem, we're going to call this outside arc 360 minus X. 360 minus the X. Okay, so you might have one like this coming up on a test or a quiz, so keep it in mind. So this here is 360 minus X, and we're calling this as X. Okay, that's what we're trying to find. We're trying to find CE, or X. Okay, so this is set up this way. 52 is equal to 1/2 times the difference, 360 minus X. And then we're going to subtract this X. Okay, that's how you set that problem up. So again, the same kind of process here. We're going to multiply by 2 on this side, and on this side, you get 104. 104 is equal to 360 minus, and these are two like terms, 360 minus 2x. Okay, so keep solving for x. We're going to subtract by 360. And we'll subtract 360 again. On this side, and you end up with minus 256 is equal to negative x, negative 2x, I should say. And we're going to divide by -2 on both sides. And that becomes x equals, cancel, 256 over 2, 128. 128. So you might need to set your problem up, designate your arc that you're looking for as x, and then the other arc that you're working with, 360 minus x. Okay, last two today for this section 9-6. Ooh, here we go. So we have 4x as the measure of the angle. We have 35 as the arc, and we have this arc out here at 9x plus 26. Okay, so let's go ahead and set this up. So we have the 4x. Then we're going to say, well, if that's equal to 1/2 times the difference of 9x plus 26, and then we're going to subtract 35. So forge ahead, set your problem up exactly the same way. Now we're going to multiply by 2 on each side to solve on this side and this side. That will give me 8x on the left. And on the right, I will have 9x. And then 26 minus 35 is -9. -9. Okay, so solve for x. So subtract the 9x from this side, subtract 9x from this side, and you'd have a -1x is equal to -9. And x is equal to 9. X is equal to 9. That's what you're trying to find. You're trying to find out what x is in this case. For example, 4a. Okay, set up your problem. Use your algebra skills. Sorry about that, a little messy there. And let's get started on the last one on section 9-6 on page 4 here, which is this one. Oh boy, kind of hard to see here a little bit. Maybe I'll zoom in a little bit here. Oh, that's zooming out. All right, that's a little bit better. Okay, so you're given that this angle is 3 degrees. You've got this arc inside. You got 4x plus 8. You have this arc on the outside, 5x minus 6. So let's go ahead and first put your 3 degrees down. That's going to equal 1/2 times the difference of 5x minus 6. 5x minus 6. And then I'm going to subtract 4x plus 8. Now I got to make sure I put this, I've got a parenthesis here of 4x plus 8. Okay, and what we do is when you're adding and subtracting this, you want to make sure you're subtracting the opposite of that positive 4x. You're subtracting 4x, but you're also going to, instead of adding 8, you're going to end up subtracting the 8. Okay, so don't forget to put your bracket in there, or your parentheses and brackets. There you go. I'll move my face up there. Okay, so let's first take care of this 2. Let's get rid of the 2. Multiply both sides by 2. And you end up with 6 is equal to 5x minus 6. Now let's walk through this together. 5x minus 6. And we're going to subtract the 4x. And we're also going to end up subtracting the 8. Okay? And again, because of you're subtracting the binomial, the whole entire thing. So it's almost like distributing that negative into that polynomial. Okay, so you subtract 4x and you also subtract 8. Some people would say it also that, think of it, when you're subtracting, you're adding the opposite. So you're adding the minus 4x and adding a negative 8. Okay, little review for you. You've had that last year. Okay, so let's move ahead. 6 then is equal to 5x minus 4x. Okay, 5x minus the 4x, got those two, and that's going to give you an x. And then negative 6 minus 8 is negative 14. Okay, so add 14 to both sides. You get x is 20. X is 20. So good little problems that are relating to 9-6, which is secants, tangents, and angle measures. Okay, hopefully this was good and helpful to you. Just a reminder, the last page of notes is basically a chart here. And basically it will help you with your circle and angle relationships. Okay, so if you think of it this way, if you have a vertex of an angle on the circle, you're going to be using this. The measure of angle 1 is equal to 1/2 of the x. Okay, if you have a vertex of an angle inside the circle, okay, like you see this angle 1, the measure of angle 1 is equal to 1/2 times the sum of x and y. 1/2 the measure of the sum of the intercepted. And the last one in this little chart for you is outside of the circle. If you have an angle measure, you can see that you have 1/2 the measure of the difference of the intercepted arcs. So again, this is 1/2 the measure if it's on the circle. Take a look. This is inside the circle, and this is outside of the circle. Okay, so on the circle, inside the circle, outside the circle. And that little chart there for circle and angle relationships kind of sums up what we've been doing lately here in the last few sections. And that concludes the lesson. I know it went a little long, but it's kind of nice just to keep it all in one lesson here. Hope you found that helpful, and we'll talk with you soon. Take care. Bye-bye.